In this example, we're going to evaluate the line integral, and we're going to do so over this space curve, which is defined by actually two curves. Now, there's direction noted in this picture. We haven't really talked about the fact that we're integrating along a path in a specific direction. In this example, if we do not follow the correct order, we'll still get the correct answer. But moving forward, we're going to really need to make sure we're paying attention to the order in which we are traveling along these paths. So in this situation, we have two curves. I'm going to think about C1 is that curve X, and my second path, C2, is X squared. And since we are integrating along two different curves, we're going to need two different line integrals. So I'm going to need to find two calculations, and then I'm going to add them together. So the first piece we'll do will be along C sub 1 equals X. So the curve we have here is y equals X, and we need to figure out how to parametrize that curve. Well, y equals X, so if X equals T, then y equals T. And my T value is going to go from 0 to 1. X goes from 0 to 1, X is equal to T, T goes from 0 to 1. So setting this up, the line integral across C1 of X ds is the integral from T equals 0 to T equals 1 of X. Well, we need to define X parametrically. In this case, X is equal to T. And then ds is going to be the sum of the squares of these two derivatives, square rooted. So the derivative of each of those is 1. So we have the square root of 1 squared plus 1 squared dt. All right, so that's equal to my ds. Again, derivative 1 squared, derivative 1 squared. We're going to get root 2 here. So this is pretty easy for us to integrate. I have the square root of 2 from 0 to 1 of t dt, which is root 2 over 2t squared, evaluated from 1 to 0, which gives us root 2 over 2. So the line integral over this path is root 2 over 2. So now for our next path, pay attention to where my t's are going from. We're going to be going from 1 back to 0. So let me clean up my screen and then we'll do part 2. Now in this situation, if we try to parametrize this curve the way we did last time, it's not going to work out exactly like we want it. So what I mean by that is, for example, if I said, okay, well, I'm going to let x equal t, then that would mean y is t squared. Well, if I plug in t equals 0, t equals 0, 0, that's going to start me at this point. I want to start at this point 1, 1 up there. So how can I redefine these so I'm starting at 1, 1 and ending at 0, 0? And the way we'll do that is we'll say x equals 1 minus t, then that means y is 1 minus t squared. Again, looking at t from 0 to 1. So now if I plug in 0, I get 1. And if I plug in 1 here, I would get out 0 for my x values. Same for y. And this is kind of a funny example because it would still work out the same if you had chose that wrong parametrization. But in some examples, you really do need to pay attention to the order or the direction of your path. So that means here, my line integral across c sub 2 of x ds. Let's define that. So here we're going to have t going from 0 to 1. My function x is equal to 1 minus t, right? That's my x value, 1 minus t, and there's x. And then ds is the sum of the squares of the derivatives all under a square root. So my derivative x, dx dt is -1. I'll write this out. So we've got the square root, we've got -1 squared plus my derivative here, I'm going to say 2. So I have 2, 1 minus t to the first, and then by the chain rule, we'll have a -1 dt. And that second derivative there, all of that needs to be squared. All right, so make sure you understand how I found my x and my ds value. So let's clean this up and solve this piece. This is the integral from 0 to 1 of 1 minus t. Under the radical, I have 1 plus 4 times 1 minus t, quantity squared, dt. Doing a u substitution here, we'll say let u equal what's under the radical, 1 plus 4, 1 minus t squared. So that means du is 8 times 1 minus t times -1 dt, or -1/8 du is 1 minus t dt. Changing my bounds, if I plug in 0 to my u equation up here, I'll get that u equals 5. And if I plug in 1, I get that u equals 1. So my substitution looks like -1/8. We've got the integral from 5 to 1 of u. That was under the radical, so I'll make that as a 1/2, and then du. Of course, I don't like my bounds being in the wrong order, so I'll negate the integral and reverse my bounds. U to the 1/2 du. So integrating that, I'm going to have 3/2 as my power, 2/3. So I have 2 over 24 out in front, or 1/12. U to the 3/2 evaluated from 5 to 1, which calculating that, I get 5 root 5 minus 1, all divided by 12. So that is the value of the line integral across c sub 2. So again, I'm going to clean up my screen. I'm going to write that up at the top. So my final answer here, I've got c sub 1 and c sub 2. So there's my line integral across this path, and then along my second path, the line integral across all of c, and c is this entire path traveling this way, going to that point, turning around and coming back to the origin. The line integral across all of c for x ds is equal to root 2 over 2 plus 5 root 5 minus 1 over 12. And so that's our final answer here. Now, remember, when I talked to you about parametrizing this second curve because of direction, I said that we couldn't do it the first way I wrote down. And so what I mean by that, I said, well, I'm going to let x equal t for c sub 2, then y is t squared, and t is between 0 and 1. We said that didn't work considering direction, because if I plug in 0, I get out 0, I start here, and I'm traveling the wrong direction. In this case, it would work out if I had parametrized it that way, and I had said, well, from 0 to 1 of x, which is t, and then times the square root. The derivative of x with respect to t is 1 squared. The derivative of y with respect to t is 2t squared dt. So integrating this, we get that exact same answer that we just got for our path along C sub 2. And this only works because we're in ds. We have that arc length parameterization. All right, eventually we're going to have dx and dy, and the order will really matter. So that's why I wanted to stress that to you at this point, even though we're not quite there yet. But we're beginning to talk about integrating along these paths in a specific direction. So that's it for this video. As always, email, comments, questions, concerns, anything. Be safe and have fun.